Welcome to This Explainer. We're diving straight into the absolute bedrock of information technology today. We're going to take a trip from the microscopic, invisible bits of data all the way up to those complex, heavy machines sitting right in front of you. So, whether you're gearing up for a board exam or honestly just want to finally understand how the device you're using right now actually works, you are in the perfect place. Let's get into it.
Here's our quick roadmap for today. We're looking at memory's smallest building blocks, how we scale up to exabytes, the physical hardware, the invisible software, how they form the perfect partnership, and we'll wrap up by testing your IT knowledge. Kicking things off with Section 1, Memory's Smallest Building Blocks, From Bits to Words.
All right, the foundation of literally all computing is the bit. It's a handy little mashup of the words binary digit. This is the absolute smallest unit of memory in a computer, and it's incredibly simple because it can only hold one binary value. It's either a 0 or it's a 1. That's it. Every single photo, document, and video your computer processes starts as this massive, sprawling collection of these simple zeros and ones.
But, a single 0 or 1 isn't going to get us very far on its own, right? So computers bundle them together. If you group 4 of these bits, you get a nibble. Cute, I know. But the one you'll hear about way more often is the byte. A byte is exactly 8 bits. Why 8? Well, it's just enough digital real estate to store one single character. So every time you type an A, a B, the number 1, or even a % sign, your computer is using exactly 1 byte of memory to lock that in.
Moving up just a bit from the byte, we run into what's called a word. Now, a word is a group of bits that your computer CPU processes all at the exact same time. The size of this word? That depends entirely on the specific processor you've got under the hood. So when you hear tech folks talking about a 16-bit, 32-bit, or a 64-bit processor, this is exactly what they mean. It's just the size of the word that CPU can chew on at any single moment. Moving right along to Section 2, scaling up to exabytes and navigating memory size units.
Okay, take a close look at the math here. Once we establish that 1 byte equals 8 bits, every single step up the ladder from there multiplies the previous unit by exactly 1024. So 1 kilobyte is 1024 bytes. 1 megabyte, 1024 kilobytes. 1 gigabyte is 1024 megabytes. This exact same multiplication just keeps going, carrying us all the way through terabytes, petabytes, and finally up to those massive exabytes. It's kind of like a giant digital Russian nesting doll.
Now, if you're a student, memorizing this exact order from smallest to largest is an absolute must for your exams. To make it super easy, here's the first half of a really handy shortcut phrase. Just remember, boys need big knowledge, many good. See how that works? It perfectly matches up with bit, nibble, byte, kilobyte, megabyte, and gigabyte.
Let's finish that thought. Teachers prefer excellence. That brilliantly finishes the list, taking us through terabytes, petabytes, and exabytes. So the whole shebang is, boys need big knowledge, many good teachers prefer excellence. Lock that phrase in your brain, and I guarantee you'll never mix up your memory units again.
Okay, on to Section 3, hardware, the physical machine, and what you can see and touch.
So when we use the word hardware, we are talking strictly about the physical parts of a computer. Basically, if you can see it with your eyes and physically poke it with your finger, it's hardware. These are the components manufactured in a factory somewhere. And because they're physical objects living in the real world, subject to friction and heat, a huge defining trait of hardware is that it can and absolutely will wear out over time.
We can actually categorize all this physical machinery based on the job it does. First up, we've got input devices. These are the tools sending data into the computer. Think your keyboard, your mouse, a scanner, or a webcam. Then we flip it around to output devices, which take data from the computer and push it back out to you. That's your monitor, printers, speakers, or projector. And finally, storage devices. These are the physical homes for all those bytes we talked about earlier, like your hard disk, an SSD, a pen drive, or even a good old-fashioned DVD.
Section 4, software. The invisible instructions telling the computer what to do.
Software is the total opposite of hardware. It's the set of programs or instructions that explicitly tells your computer how to behave. It is completely intangible. You can't see it as a physical object, and you definitely can't touch it. And the best part? Unlike that physical keyboard where the keys might get stuck after a few years, software can't physically wear out. It's purely logical.
You're interacting with software every single time you use a device. In a broad sense, this covers the big operating systems managing the whole show, like Windows or Linux. but it also includes every specific application you fire up. Microsoft Word for typing, Excel for crunching numbers, Google Chrome for surfing the web, or even Paint for making a quick sketch. That's all software.
Which brings us to Section 5, the perfect partnership. Let's see how hardware and software actually interact.
Here is the golden rule you need to remember. They are entirely codependent. Hardware cannot work without software, and software cannot run without hardware. Think about it. You could have a $10,000 gaming rig sitting on your desk, but without an operating system installed, it is quite literally a very expensive paperweight. On the flip side, the most beautifully coded piece of software is completely useless if there's no physical processor to run it or screen to show it. Looking at their contrasting traits is a really great way to summarize this, especially if you're prepping for a test. Hardware is physical components, software is instructions. Hardware can be touched, software absolutely cannot. Hardware is manufactured on an assembly line, software is developed by programmers typing code. And again, hardware wears out over time, while software is immune to physical wear and tear.
Let's look at some real-life pairings to see this partnership in action. Your physical monitor needs software like Windows 11 to actually display a user interface. That physical keyboard on your desk, you use it to type words into the MS Word software. Your mouse is the hardware tool driving the cursor inside the Paint application. A physical printer outputs the web page you pulled up using Google Chrome. It's a constant, seamless dance between the tangible and the intangible.
Finally, Section 6. Test your IT knowledge.
It's pop quiz time! Let's see what's stuck. Quick, for 1 mark, can you define the absolute smallest unit of data? What about that 8-bit group we talked about? How would you define the physical machine versus its invisible instructions? Try to picture those zeros and ones, the character storage, and the whole tangible versus intangible concept we just covered.
All right, moving up to 2 marks. Can you write out that complete hierarchy of memory units from smallest to largest? Pull up that mnemonic shortcut in your head, boys need big knowledge. See if you can finish the phrase and list out the exact sequence from bit all the way up to exabyte.
And for the big 5 marks, the ultimate test. Can you clearly explain the differences between hardware and software, and then give suitable, real-world examples of how they pair up? If you can confidently explain how your mouse interacts with a specific app on your screen, you absolutely nailed this.
If you breeze through those questions, huge congratulations. You have officially mastered the basics of information technology. But, realizing that software is just a bunch of invisible instructions leaves us with a pretty fascinating question. How do all these vastly different types of software, from the core system managers all the way to your favorite utility apps, actually organize and juggle all those complex tasks behind the scenes? Well, keep that curiosity alive, and we'll unpack exactly that in our next explainer.